This is Geometry, Lesson 7-1, the Pythagorean Theorem. I'm recording in the car, so that's why there's background audio. First, I want to talk about the theorem. So first, the thing you need to remember that we're talking about a right triangle first. If you do not have a right angle mark, then you are not allowed, you're not permitted to use the theorem. Everything in the homework will not be a trick question. They will all have this right angle. So if you have a right triangle, and again, as a way to mark this up, a right triangle here means that I'm 90 degrees. If you have a 90-degree triangle, then the following is true. The side length and side length squared, if you add those together, it will be equal to the hypotenuse length. And again, these two sides, A and B, they can be interchanged. B can switch with A. It doesn't matter the order that these go in. So I will just make a note here that A and B, these are what's known as the legs, and C is known as the hypotenuse. All right, and I will make a note here as well that these are interchangeable. All right, so let's do an actual problem. In example 1, I want to solve for x. Notice that we have a right triangle, which means we have permission to use the Pythagorean theorem. We have a leg, we're missing a leg, and then we have the hypotenuse. So since we have permission to use a right triangle, since we have permission to use the Pythagorean theorem rather, let's go ahead and set that up. So I'm gonna have a squared plus b squared equal to c squared. And I'm just going to randomly say you are a, you are b, you are c. Therefore, a is going to turn into an x, so I'll have x squared plus 6 squared. I know my 6's and b's look kind of similar. That's going to be equal to 10 squared. So x squared is still x squared, 6 squared is 36, 10 squared is 100, and I'm going to subtract 36 from both sides. And when I do that, these cancel out, leaving me with x squared is equal to 64, and then from there to undo the square root, I'm going to square root the left and right side. The square and square root will cancel each other out, leaving me with just x, and the square root of 64 is 8. Normally, whenever we take the square root, we have to do a plus or a minus, but because we can't have a negative length, I ignore the minus, and I know that the answer has to be a positive 8. So I can go ahead and box my final answer. X is 8. All right, in example number 2, I have another triangle. This one is a little bit different though, because one of the side lengths has this square root. And in this case, I have 2 legs and I do not know the hypotenuse. Again, how do I know that it's the hypotenuse? It's the one that is across or the opposite of this 90-degree angle. It is the longest and diagonal side. So I know that I have a leg squared and leg squared, and that's gonna be equal to x squared. Let's go ahead and set up Pythagorean theorem using the fact that we have a right triangle and see what we get. We're gonna have a squared plus b squared equal to c squared, and I'm just gonna say you're a, you're b, you're c. Again, I could have said this is a and this is b. It doesn't matter, they're interchangeable. So I'm going to fill into the formula here. I'm gonna say that the square root of 51, that quantity squared, plus b, which is 5 squared, and that's gonna be equal to c, which is x squared. And from here, remember that a square root and a square cancel each other out. They are inverse operations of one another, so square root and square is gone, leaving me with just a 51. And then I still have to do 5 squared. 5 squared is 25. And that's going to be equal to x squared, which is still x squared. And there's a plus sign in here. I can simply add 51 and 25 to get to 76. That's equal to x squared. And then from here, I'm going to square root the x squared and then square root the 76. Again, the square root and square are inverse operations, so they're going to cancel each other out, leaving me with just the x. And then over here, the square root of 76, I think that it could be factored, so I'm going to be careful. I mean, I think the answer is square root of 76, but it might be able to be reduced. So let's go ahead and check. Let's go ahead and do a factor tree. 76, I think 4 goes into that. I think 4 times 19, the square root of 4 times the square root of 19 is the square root of 76. How do I think about that? Well, I know that 20 times 4 is 80. This is really close to 80. It's 4 away from 80, so I went 1 down. So it's 4 times 19. And remember that 4, that's going to turn down in here to just a 2. So my final answer is going to be 2 square root of 19. And I'll box that. All right. And then finally we have example 3. the hardest of all of them. I realize that the homework does not have a mixture of numbers with radicals, but they might show up later, so I wanted to cover it right now. Again, I have a right triangle, so I have permission to use Pythagorean theorem. Pythagorean's theorem is always useful for finding side lengths of a 90-degree triangle. Let's set this up. I have a squared plus b squared is equal to c squared. Let's go ahead and kind of randomly label, just say your a, your b, and your c, which means a is going to be an x squared plus b, which is the square root of 5, that quantity squared, and that's going to be equal to that 2 square root of 3, that entire quantity squared. All right, so this x squared, nothing can happen. I'm just going to rewrite x squared. Notice what's happening here. I have a square root and a square. Those are inverse operations, therefore they will cancel each other out, leaving me with just a 5, and that's going to be equal to, and this is the tricky bit, what happens when I have a non-square root and a square root that are both to a power of 2? And the answer here is you distribute this 2 into both of these two numbers, and this is really 2 squared, that's supposed to be a squared, let me make that look a little bit better, 2 squared, square root of 3 squared. And note that this square root of 3 and that radical symbol and this square do indeed cancel each other out, so I can cross and cross, and I can rewrite this as x squared plus 5 is equal to, okay, 2 squared is 4, and then the square root and the square cancel each other out, leaving me with just a 3. This is 4 times 3, and 4 times 3 is 12, so I'm going to have a 12 over here. I'm going to rewrite everything else. And then from here I can subtract 5 on both sides, subtract 5 on both sides, and x squared will be equal to 7. And then from here I just need to undo the square by square rooting, and notice now that the square root and square cancel each other out, leaving me with just an x. On the right hand side I have the square root of 7, and because that is a prime number, I know it cannot be reduced, and I can say that x is indeed equal to the square root of 7, and I can just box that final answer. Alright, as a freebie for my class watching this, I will go ahead and give 2 free answers on the homework. I'm going to do an easy problem and a hard problem, or what I view them as easy and hard. Let's get everyone started on number 1 first. So in number 1, in all of these, we have a right triangle, therefore we are allowed to set up Pythagorean theorem. We can say that a squared plus b squared is equal to c squared, and I'm just going to say your a, your b, and your c. It's super important to make sure that c is always across from the 90-degree angle. Across is not the technical word. In geometry, we use this term that means across, which we call opposite. It is opposite of this angle. Opposite of the angle is always on the opposite side of these 2 legs. All right, so I'm gonna plug things in. I'm gonna say that I have a 12 squared plus an x squared is equal to a 13 squared, and then I'm just gonna multiply these out. So I have a 12 squared, which is 144. Here we go. 144 plus x squared, can't do anything there, and leave that equal to 13 squared is 169. And then from here, I'm just going to subtract 144 on both sides, subtract 144, and get x squared is equal to 25. And then from here, I just need to undo that square by square rooting, and x therefore is equal to the square root of 25, which is 5, and I can box that answer. Let's go ahead and check to see if we got that one right. X should be 5 for number 1. Number 1, x is equal to 5. I'm checking my work. Good job. All right. What number? I'm going to choose number 9 randomly. How would I do number 9? Well, again, I have a right triangle, and I'm talking about side lengths, so this must be Pythagorean theorem. Let's go ahead and plug into a squared plus b squared is equal to c squared. The most important bit is which one is c. It's the one that is opposite of the 90-degree angle, so u must be c. We'll label that c, and then it doesn't matter how I label the rest of this. This can be a, this can be b. All right, so a is going to be the square root of 13. That quantity is going to be squared, plus b, which is the square root of 5. That quantity is also going to be squared, and that's going to be equal to c squared, which in this case is x squared. So notice we're going to have a lot of cancellation. This square root symbol and this 2, the square root symbol and that 2, which is really power of 2, they're all going to cancel out. So cancel, 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 and what I'm left over with is 13 plus 5 is equal to x squared. 13 plus 5 is 18. That's equal to x squared. And to undo this square, I need to square root both sides. And my answer is going to be something similar to the square root of 18. The problem is the square root of 18 can be reduced. It's not a perfect, or it's not a prime number. So let's go ahead and do a factor tree for the square root of 18. One of the factors of 18 I know is a perfect square is the square root of 9. And square root of 9 times square root of 2. Remember, square root of 9 is the same thing as 3. So my final answer will be 3 square root of 2. Final answer, which I will then box. Or I guess trapezoid. It's 3 root 2 for number 9. Number 9. 3 square root of 2. Make sure you're checking your answers. I'm looking at a lot of these problems. It looks like number 5, 6, 7, 8, 4, and 10. All of those numbers have to be reduced because they have a number out front as well. Remember that you should be doing that. All right, that concludes my lesson for lesson 7-1, Pythagorean theorem. Thanks for watching.